section 10.3 because I want to teach you some application of combination idea. To teach you some probability distribution is called binomial probability distribution. Okay, that's my extra topic for you. I'm not going to put a test question or final exam question from this section. No homework or anything from this section, just kind of extra one, because I think it's beneficial you learn how the combination idea can be used in probability theory. Okay, so let me go over that one, and then I will explain the last problem of the practice problem, final exam practice problem. Okay. We talk about binomial distribution under discrete probability. Okay. Yeah, under discrete probability distribution. So first of all, probability distribution means it tells you the probability of different outcomes that can happen in a given experiment. For an example, if you toss a coin 3 times, now you know I wrote down all the possible outcomes. There are 8 possible outcomes you have. I wrote down all those things. Okay. So you may ask, what is this omega? This is how we represent sample space. If you take a stat class or probability class, you may already know those notation. You can use omega, or some people use S. Okay. So to give you where we can use combination idea, I create this problem. Like think I want to measure the number of heads. This is X. It's called a random variable because number of heads can be changed depending on each event. Here number of heads is 3. Here number of heads is 1. So each event gives you a number, which is number of heads. So it's like a function. If you put an event to the random variable function, it counts how many heads you have. Okay, you can think it's like that. So probability of head, I say P. That's the chance of head happen. You may say, okay, if we have an unbiased coin, it's 50%, 50% chance. Yeah, then it's like 0.5 is the probability of head. If you subtract 0.5 from 1, it's 0.5. Okay. So this is how you can think, but it's not always. It's not always 0.5. Okay. If you have biased coin, it could be different. Okay. So I choose it's like a P, the probability of head, and 1 minus P is the probability of tail. For an example, if probability of head is 20%, this is 1 minus or 100% minus 20% is 80%. It's like 0.2. This is 0.8. Okay, right. So I am counting the probability of 2 heads. What is the probability that 2 heads can happen? 2 heads can happen in these 3 situations. Clear? Right? Because there are 8 different situations we had. Okay, so I'm going to erase these things and explain. There are 8 different possibilities, but 2 heads can happen. Here is the 2 heads, and here is the 2 heads. Only 3 situations we have 2 heads. Okay. So this situation, the probability of head happen is P, and another head, so P. The other one is tail. So this is the probability that you can have 2 heads and 1 tail. So it's P square times 1 minus P. This is the probability for 2 heads and tail. How many 2 heads and tails we can have? 3. So that's why it's 3 here. So I wrote down all those 3 situations. It's 3. Actually, that 3 is very important because I can count this number always. I can find that because it's always 2 head and 1 tail. But it's very interesting how many 2 heads and tail happen here. That can be calculated by 3 possible choice. Um, here you have 3 possible options. How many 2 heads can have? Because the length of this is just 3 for each one. But I'm concerned about how many 2 heads. So it's 3 factorial, 2 factorial. The difference is 1 factorial, okay? It's just 3. That's how this number comes. Actually, 3 is, here it's clear because I highlight them. But if you have so many, if you toss a coin 10 times, how many 2 heads can happen is very different than if you toss a coin 3 times. So that's the application of combination idea. So this 3 choose 2 come into play in the binomial distribution. Okay. So this is another way we can write 3 choose 2. You can write 3 choose 2 or 3 choose 2 in both ways. Okay. So I asked the question, okay, what about if you toss a coin 10 times and you get 6 heads? So just think about if you get 6 head, you have p to the power 6y because it's 6 times the head happen. If 6 times head happen, how many times the tail happen? 4 times because you are tossing a coin 10 times total. But the interesting thing is how many different outcomes you have 6 P's or 6 heads like this, You can have 6 heads and then all tails. Okay. And you may have 2 tails and 2 heads and maybe another 2 heads and all the others are heads. Right? This is another possibility. You can have 6 heads. How many possible ways? How many ways you can select 6 head out of 10 possible array? This is like an array. So 10 possibilities because you toss a coin 10 times. But how many ways how many ways 6H can occur? How many different locations you have? That can be counted and it will be equal to 210. Okay. Let me show you how I get that number. 10 to 6, 10 factorial. The difference is 4 factorial. And you have to put the 6 factorial here. Okay. So 10 times, 9 times, 8 times 7. And 6 factorial can be cancelled out with this. 4 factorial is still there. So 4 times, 3 times, 2 times 1. I'm not going to write 1. So 4 times 2 is 8. Cancel out. This is 3. So 30 times 7 is 210. Okay. That's mean there are 210 different ways you can have 6 heads and 4 tails. So you have to multiply this quantity with 210 to get the correct probability. This is a little complicated, not complicated, but it's, you can take your time to understand. Here, I write down a notation to tell you a kind of a probability distribution formula, like it's called binomial distribution. But don't worry, this is like a kind of a notation. So here you can say X mean how many heads you are interested. Like if you toss a coin 10 times, I am interested about getting 6 heads. So it's my 6 heads. N mean how many times you toss a coin, 10 times. And what is the probability of getting a head? So here I use P, but if you think, oh, this coin has 60% chance to get the head, then you can put 0.6. Okay, this is really the combination formula. Okay, so let me do one example, then you can understand what's going on here already. So this is my example. According to the recent research, 51% of American adults own a tablet. Okay, so that means on a tablet has percentage 0.51. So that's my percentage of on a tablet, but I need not all six. I select 6 people. For an example, I have this probability is given 51% chance. If you choose any American, he or she has tablet. The percentage of that person on a tablet is 51% or 0.51. So in my class, if I ask 6 people, do you own a tablet or not? So I can select 6 people and ask, and what is the probability 4 of them on a tablet? That's what I'm gonna find out. Okay, 4 people on a tablet out of 6 people I choose. So this is the way you can select 4 people out of 6. And how many people own a tablet out of 6? 4 people own a tablet, which is 0.51 raised to the power 4. If 2 people own a tablet out of 6, how many people do not own a tablet? 2 people. That's their probability. And how many ways I can select 4 people out of 6? You can write it like this. That's the notation I use here. But it's like 6 factorial. The difference is 2 factorial over 4 factorial. So if you simplify 6 times 5 times 4 factorial, 4 factorial cancel out in the bottom. So it's like 30 over 2 because 4 factorial cancel out. So it's 15. That's the 15 here. And you can, simplify these two and you can get, it's around 24%. That means I asked 6 people, the probability that four people on a tablet is 0.25% approximately. What is the probability all people on a tablet? If I select 6 people, everybody on a tablet mean this situation. That means all 6 people on a tablet. No, it's like if you choose a probability of a person who on a tablet, let's say T, probability of all 6 people on a tablet is 0.51 to the power 6, because you have to select 6 people out of 6 because I need everybody on a tablet. So 6 choose 6 is just 1. And what is this 0 mean? No one, there's no people without a tablet because I'm looking for all the people on a tablet. So that's become 1 again. So this is the only remain. Right. So this part I will explain, but remember this section, I'm not going to ask a question, final exam question from this problem, this concept or section. Okay. This is an extra section for your knowledge. Less than 3 people on a tablet. So that means you select, you have 6 people, you survey. There's a probability for no one on a tablet, or 1 people, 2 people on a tablet, because I'm looking for less than 3 people on a tablet. So this is the probability no one on a tablet. This is the probability that 1 people on a tablet. This is the probability that 2 people on a tablet. So you calculate each one. So 2 people on a tablet situation, let's discuss that. 2 people on a tablet mean this is the probability of on a tablet you raise to the power 2. There are 6 people, so 2 people on a tablet mean 4 people do not own a tablet. So how many ways you can select 2 out of 6? This is the combination. Okay. So the other possibility you can get is at least 4 people on a tablet. At least 4 mean it could be 4, 5, 6 on a tablet. You can get the get that probability by subtracting less than or equal 3 from 1. Okay, and it will be 0.3627. Right. So these things, there are something called mean and standard deviation in probability theory. You may heard about that. So mean of a binomial distribution is can be calculated n times pi. Pi means the probability. For an example, our example number 2, the probability of on a tablet is 0.56. If you survey 6 people, you multiply that with the 0.51. This is the average of people on a tablet. The standard deviation can be calculated using this formula. Okay. Yeah, so I think that's a good application. Why we learn combination.